So that's cloud computing. And the next question we get to is it really energy efficient? Because lots of people say it is, and even Nancy alluded to that report from the Carbon Disclosure Project, which I'll blow apart in a minute. They weren't the only ones. Microsoft, Accenture, and WSP Environment brought out this study in November of last year. And this is the actual title of the study, where they say it shows significant energy and carbon emissions reduction potential from cloud computing. And again, the link to the report is down there at the bottom. The difficulties I have with that are several. First is Microsoft are a cloud computing provider, so they've kind of skin in the game. The second is that they don't actually use any hard data. It's all imputed. And the third is that after months and months of work from all these people, the best they could come up with is they could say it has potential. Yeah, it has potential to end world hunger and bring on world peace and fix the euro. Anything can have potential. So that's a non-report. Cloud computing has phenomenal advantages, don't get me wrong. I'm a big fan. So if you're into traditional IT, you know well that if you're deploying a new application or a new server, it's painstaking. You have to go through an RFP process, a speccing process, a PO process. You have to go out to tender. You have to place the order. The order then can take several weeks from the supplier. When it comes in, it goes into the logistics area. You've got to get the guys in warehousing to tell you where the server is. You've got to go get the server. You've got to put the company image on the server. You've got to install the applications. You've got to do testing. You've got to patch the server. The list goes on and on. Basically, you want to deploy a new server. It's a process that can take weeks to months. You deploy a cloud application. There's usually no RFP and no PO process because the capital cost is minimal. So typically, the time to deploy for a cloud application shrinks from weeks to months to hours to minutes, depending on what you're deploying. So phenomenal. Cloud is fantastic for streamlining that kind of stuff. It's also great for what's called dynamic provisioning. So this is the Alexa graph, the website traffic of a website for the Australian Open. The Australian Open is a big tennis competition, happens in Australia every January. So you'll notice 11 months of the year, no traffic to the site. Come December, January, boom, spike. That's 2006, 2007, larger spike, 2008, larger spike, and the spikes keep getting bigger as you go that direction. So if you were the website owner for the AustralianOpen.com website, you would need to have, if there were no cloud computing options, you would need to have servers that could hit and deal with the traffic at this growing spike for 12 months of the year when the traffic is only there 1 month of the year. But with dynamic provisioning and cloud computing, you can use the elasticity of the cloud to turn up the resources assigned to that site as the traffic starts to build up in December and January. And then as the traffic falls off, you turn it back down again. So in that respect, cloud computing is fantastic as well. You're not using resources needlessly. We've also got the idea of multi-tenancy, and if you can't see what's in this picture, it's actually a Mini Cooper with 26 people inside in it. EMC sponsored it as the world record attempt to fit people into a Mini Cooper, and they fit 26 people into it. So they stuffed people into it. With multi-tenancy in cloud computing, it means you're sharing applications across companies. Lots of different companies, often competitors, are using the same single version of the application. And that's fantastic. That adds great value. You know, you've only one instance of the application, which is great as well for updates. Updates of the application are instantly deployed. You know, you don't have to download the latest update and apply it to the test server, make sure it works in the environment, the whole thing. No, it's just instantly on. There's the issue of server utilization, which again Nancy referred to. Nancy, you stole my talk. Come on. So this is a typical graph of server utilization. And you can see this is the memory part, but this is the server utilization, and it's at 0% here. And while that's a bit of an outlier, you'll often get, in normal servers, you'll often get utilizations in single digits, 7-8% server utilization for traditional servers in data center environments. But with the advent of virtualization and cloud computing, you can ramp that up significantly. So that should be quite energy efficient. Then you've got this kind of outlier thing called chasing the moon, which you may or may not have heard of. It's one I'm kind of fond of as an idea, but not many people have deployed it yet. People are kind of talking about it as out there. And what it is with cloud computing, if you've got data centers in, say, US West Coast, another in Northern Europe, or Southern Europe, but Northern Europe typically because it's cooler there. And cooler, I mean colder, not hip and cool. And you've got another data center, say, somewhere in Asia or Eastern Russia. Then you've got the time zones covered about 8 hours apart. So if you have applications in those, if you have an application in those 3 centers, you can move the compute to where energy is cheapest at any particular point in time. So if you're doing that, typically energy is cheapest when it's in highest supply. When it's in highest supply and it's cheapest, it's actually, this is on the wholesale market, it's actually greenest as well. So when electricity is at its cheapest, it's actually also at its greenest. It's kind of counterintuitive, but I can explain that to anyone who's interested later. So if you move your compute to where the energy and the compute is cheapest at any point in time, it's typically night time when the wind is blowing. And at that time, you're chasing the moon. You're putting your applications wherever the moon is out. So it's called chasing the moon. It's something you could only do, something that's only made possible by the likes of cloud computing. Your information is ubiquitous. It's wherever you have an internet connection. So your road warriors, your salespeople on the road can access the application while sitting at the beach. It also enables a lot more home working, home shoring, teleworking, whatever you want to call it. And people like AT&T, IBM, lots of big companies are huge fans of this. IBM reported a couple of years back now that 25% of their employees did teleworking, and those 25% were saving IBM $700 million a year. That's significant savings. And a lot of that savings comes from a lower real estate footprint and a lower energy footprint because of the lower real estate footprint. So is it energy efficient, or are a lot of those savings coming from less commuting or from less building stock? Or are they from offsetting your energy? So if you're working from home, you're still burning energy. It's just not in your company's building, and your company isn't accounting for it anymore. These are kind of questions we're not sure of. There hasn't been any definitive studies either way, and it's difficult anyway because it differs in every company and every geography. One huge problem I have with cloud computing, and people saying that cloud computing is energy efficient, is that none of the cloud providers are publishing data around their energy utilization. Not one of them.